Satvika from CSE A section. My topic is floating point numbers and operations. Understanding decimal values in computers, how floating point numbers are represented and calculated, applications, precisions and common problems. Simple example, 6.25 into 10 power of 2. This example, sign is plus, exponent is 2, significant is 6.25. What are floating point numbers? Floating point numbers are that contain a decimal or fractional point. Example, 3.14, 0.5, 12.75, 100.25. Useful when whole numbers are not accurate enough. The decimal point can move depending on the value. Scientific notation, 123.45 is equal to 12.345 into 10 power of 1. Key idea, the decimal position is flexible, which helps represent many different values. Why do we need floating point numbers? Integers cannot represent values between whole numbers. Computers use binary internally, so many decimal values need approximation. Floating point can represent very large and very small values. It is useful in science, engineering, graphics and measurements. For example, whole 5, fraction number 5.25, tiny 0.00002, large 3.0 into 10 power of 12. Decimal and binary representation. Computers store data using binary digits 0 and 1. Decimal fractions have a simple binary form, others do not. For example, 0.5 is exactly 0.1 in binary. Values such as 0.1 may require an infinite repeating binary representation. Exact example, 0.5 base 10 equals to 0.1 base 2. Approximation, 0.1 base 10 does not have a finite binary representation, so it is stored in approximately. How floating point numbers are stored? Sign, positive or negative. Exponent, control the scale and decimal position. Sign, significant, stores the important digits. Normalization and scientific notation. A floating point value is commonly written in normalized form. The significand is adjusted so there is one non-zero digit before the decimal point. The exponent records how far the decimal point was moved. This makes representation is consistent and efficient. Example, 6250 is equal to 6.25 into 10 power of 3. Another example, 0.00625 equals to 6.25 into 10 power of minus 13. Remember, exponent equals to position adjustment. IEEE 754 standard. IEEE 754 standard is a widely used standard for floating point representation. Two common formats are 32-bit single precision and 64-bit double precision. 64-bit generally provides more precision and a wider range than 32-bit. Floating point operations. Addition. For example, addition, 2.5 plus 1.5 equals to 4.0. Subtraction, 5.5 minus 2.0 equal to 3.5. Division, 7.5 divided by 2.5 is equal to 3.0. Floating point precision. Computers cannot represent every decimal number exactly in binary. Some values are stored to close approximations. This can create small rounding differences. The error is usually tiny, but it not matter is the repeated calculations. Example, mathematically, 0.1 plus 0.2 equals to 0.2. In some programs, 0.1 plus 0.2 equals to 0.5 254g1a0504. Common problems. Rounding error. Small differences caused by limited precision. Loss of precision. Important digits can be lost during calculations. Underflow. A value becomes too smaller for the format. How to reduce floating point errors? Avoid comparing floating point values using exact equality when possible. Use a small tolerance for comparisons when approximate. Choose double precision when greater accuracy is needed. Round values only when presenting results, not too early calculations. Use decimal or fixed point methods for applications that require exact decimal arithmetic. Comparison. Instead of a double equals to b, consider modulus of a minus b is less than or equal to tolerance. Applications of floating point numbers. Scientific calculation. Uses decimal values and calculations. Weather forecasting. Uses decimal values and calculations. Computer graphics and games. Using decimal values and calculations. Machine learning and AI. Also decimal values and calculations. And engineering simulations. Also decimal values and calculations. Statistics and measurements using decimal values and calculations. Advantages and limitations. Advantages. Represents very large and very small values. Supports fractional calculations. Efficient and widely supported. Essential for scientific and engineering work. Limitations. Some decimal values are only approximations. Rounding errors can occur. Precision is limited by the chosen format. Special care is needed for exact decimal applications. Conclusion. Floating point numbers let computers work with the decimal values. They use a sign, exponent and significand. IEEE 754 is common standard for representation. Basic operations include addition, subtraction, multiplication and division. Precision and rounding errors must be considered. Floating point is powerful because it represents a very wide range of values. Key takeaway. Floating point is useful, efficient, but it not always exact. Thank you.